Alright, welcome back generals to another Let's Fix the Generals at 0 hour to make the best game ever. Last video. What did we do? We worked on unassemblize to dump symbol, to collect the symbol information from the PDB. Right. Okay, now Psychana has sent us some symbol text files for the Mac 0 hour. Let's take a look at this one. Okay. Let's open both of them. Aha, okay. Object file. A lot of these symbols look to be game unrelated. Looks more like system kernel files. Except for this. This looks like... Okay, so this looks like the mangled names. Undecorated names for functions and core. Yeah. And here's the unmangled name. Undecorated. Yeah. That's nice. Okay, so let's take some notes here, what we see. Second file contains decorated plus undecorated function symbols. And then there's some addresses here, which I suspect okay, at the very front is like an index. Ah, okay, here is like a library, but here is 0 hour Mac. Yeah. I don't know what EH is. Okay, so there's like a symbol A So maybe what is symbol type A? .eh files contains .eh files. Okay, and then we have T. T seems to be our functions. Second file contains symbol type T. Symbol type A. What is this? Contains lists EH files. Okay. And here this seems to be address. Yeah. Let's put address plus decorated name, or let's say functions. Functions address plus decorated name plus undecorated name. Function shows address plus section. It doesn't show return type. Undecorated name has no return type. Why? Sample sounds, stream sounds. Yeah, it's a bit unfortunate that we are missing the return type, but maybe it's somewhere else. Yeah, I mean, we need the return type. It's fundamental. We have two destructors here. I don't know what's up with that. And 2 times constructor. Why is that? Why is it duplicate? Oh, here. Second file, interesting data starts at this. has symbol type T function. Has what is this? Let's see. Seems to be like types. Well, it's I think this is exported symbols or import DLL import export. Yeah. Yeah. Not sure. I'm not sure. Okay. So the get data. Yeah. So I wonder, well, let's first keep looking here. Let's see what the T gets us to. Well, it's a lot. Let's scroll faster. Okay. Here, D. D is data. So T stands for text. Text. Yeah. Text function. Has symbol type D. Okay, so these are like, let's put data. That's a text segments, data segments, statics, static vars. But it doesn't tell us a type of this var. Shows okay, shows address plus decorated name plus undecorated name. Plus section shows no type, no data type. Let's say shows no return type. Okay, let's keep on looking. Aha, vtable. Aha, aha. Shows address, type info. Section plus type info plus vtable. Let's go back up a bit. Vtable. Then there's S jump table. Has symbol type S jump table. Whatever that is. Okay, let's take a look at this thing. Oh. Why is this always 0 here? Always shows as 0. Yeah. Symbols cover text addresses. Call math. Aha, here we have some return, don't we? No, we don't. It's just called return file. Okay. First file. Lists source files. Symbols cover text addresses. List source files. List source files plus global symbols plus static symbols. Plus symbol plus address range for symbols for all, for symbols combined. Global symbols. Global symbols. Functions plus data. Let's call this useless. Global functions plus data. Lists shows address, decorated name, undecorated name, type, plus type, let's put address here at the end. Static symbols are functions plus data. shows decorated name plus undecorated name, type same. Yeah, that seems to be it. Shows no return type. Yeah, so I'm missing return types. That's information that we need. We are missing some symbols are listed twice. Some symbols are listed twice. Yeah. Missing information on inheritance. Data types, function return types. Okay, so these are my first notes on this. My initial notes are overall okay, max zh notes. Let's save this in case we need it again. Good. Good. Then let's be done with this for now. Okay, back to our PDB reading effort. So I was wondering, can we perhaps implement our lookups without needing this ID map? So if we could find a way to read the public symbols here, with without iterating, then we wouldn't need by the way, I think I need some other music here. I need some concentration music. Just without any vocals. Here, deep focus. How about that? No, that's not quite right. Yesterday I listened to this, which was not bad. It's always the same, but it works. What about this one? No, that's not it. A 12-hour deep focus. No, that is way too much piano. Yeah, this could work. Okay. So, okay, compile it. So basically, we would like to read symbol, some type public symbol. So we have this find children here. Can we find children by VA? Yeah, maybe we can do that. Okay, there was one other thing I wanted to do, and that is, I think we should also store the virtual address. Oh, virtual we cannot use. Let's call it ABS virtual. Let's rename this to rel virtual. And actually, while on it, there's actually documentation about DIA, which first tells us which functions we can call on what symbols. And second, it gives us some comment, some description about certain things. So here, address offset offset part of locations. Okay, that music sucks. Let's put on the same we had yesterday. That worked for me. Offset part of location. Let's document here a little bit. Though I have to say this comment doesn't help much. Okay, so virtual address, position of the function within the executable. Let's document this. And relative position of the function within its block. Oops. Here. Okay, so basically, wherever we set this, I would also like to set the apps virtual, because perhaps this is what we will end up using. I don't know yet. Let me see. Okay, so here, let's put a WVA get virtual address, and here apps virtual. Hold on, this is a different type. It's ulong. So what we need for this is a uint address t. Address t. Let's do address 32t. Then we do using address 64t. Here we are, 64t. I don't know why it made it caps. Address. I put this here. Okay, static cast uint 64 VA. There we go. VA. Okay, and yeah, then we basically copy this to all the other places here. By the way, this, I think this we can change to divert 0 invert ulong 0. There we go. Got a fly flying here in my view. That's not nice. Okay, let's copy this to the other guys. Here. And here. And then we could here this, put it here, and here, and take this, put it there. No, it's already there. take this. There we go. Okay, this works. So now we also have included the apps virtual. The fly is still here. I want to punch it. Good. Let's remove this function here. We're not calling it, and maybe we never need it. Okay. Good. So let's see read compilant function. So basically, can we in here so let's open this one. Find children by X by VA. VA. Yeah. Okay, let's try this here. So what we do is, man, the fly, go away. So we take this here and we put that down here to a new scope. And if succeeded, let's put this in there. So here, find children by VA. And that takes SymTag. Compare flags and VA. VA. So let's put this here. And then let's put a breakpoint here. And let's debug this. Okay, so this actually succeeded. And I would expect that we now get one symbol, one public symbol for this VA, you know? No, we get nothing. Huh? Well, that is unfortunate. Find children X by VA. Fly is still flying around, still on the loose. By RA, by VA. Perhaps we have to. Find children. Well, let's put breakpoint here actually. Aha. The fly is still here. I try to catch it with my hand. It's always flying in front of my face. I probably stink, that's why. Good, okay, so actually I was wrong. It does enter here. Maybe not for everything, that could be. Okay, so we have... Let's see what this now refers to. Read public symbol. Symtag. Read public function. Doesn't find this, okay. Yeah. This would allow us to read public function. Read public. Yeah, okay, how about we here read public function and we pass function info here. Yeah. Let's comment out this one here. So read public, let's stop debugging. And put this here. And then we simply put so ulong. We don't use that. Okay, name, get name, and then function. Hold on. publics, yeah. Ah, it's, yeah. Decorated name, aha, right. Okay, let's remove this here. Yeah, actually, let's remove all this here. Okay. So if I'm not mistaken, we can simply call this read compilant function. We simply call this here. Parse function info and p symbol. And I think this would be a much easier way of doing this thing. Yeah. Yeah. How about we do that? Let's test this. We also can now remove a bunch of other things. So we can remove this one here. Let's comment out everything that we would no longer need. This one. Yeah. Anything else? Let's see. Read public function, get name, critical section, decorated name. Yeah, it works. Yeah, that's much better. Then we don't need the lookup map anymore. That's nice. Okay, let's put a breakpoint here. Here. And let's check our functions. Yeah, this looks okay. Good. This also means that we don't need this anymore, the read publics. So I wonder if we want to remove that code then. Like this. I mean, if we don't need it, might as well just remove it. So it's this here. It's this. Bool success. Public symbol we don't need. Oops. And read globals we also don't need. So can remove that as well. Okay, then let's take this. Okay. Then now there's a question. This also means that in theory, we could bag the functions back into the compilants. But perhaps we don't want to, because what we could also build is we could have a source file info, and we could there build function IDs inside, right? Source file info. Let's remove this. Let's remove this. Yeah, I think that's a good idea. So we can decide between compilant info or source file info. Yeah. Okay. Let's see if it still compiles. I should. Okay, so what is missing now is, by the way, let's see if we got any lack of return type. Is because the mangled name doesn't encode it, because C++ standard states you can't overload a function purely by return type. Lack of return type is because the mangled name doesn't encode it. Because the mangled name doesn't encode it. Well, what I can say is in PDB, the undecorated name contains public, contains access, public. Let's search for protected, just to make sure. Yeah. Private, protected, public. Return type. Calling convention. Namespace. Class. Name. Undecorated function contains name, argument types. Perhaps this info is elsewhere in Mac. Okay, back to code. Okay, so we need to maybe we put this function down here because it's called very late. Yeah, let's take all this. And move it down. Okay, we can remove this. Good. So basically, find lines by RVA. Yeah. So we could call this in the function as well. Yeah. Yeah. I think so. Okay. Let's copy this. Actually, find lines, read lines. Function. Okay, how about we take this code here and we drop that in here. P lines, find lines by, let's put here succeeded. Move this in here. Delete that. If succeeded, find lines by VA. VA. What about range? Length. ulen. Divert. ulen. Here. Okay, how do we read this now? So source lines we fill, yeah, but then what about the source file? info. I think I have an idea. Okay, so I think we need to read components. Yeah, so for starters, let's pass here also the compilant info and the compilant function, because we need it. Function info. So we have source file ID here. Source file ID. Good. Okay, it's a bit of brain melt here. Okay, so I don't think we need this because there will ever be only one document. P line, read line. So I think we need to pass down. No, let's do int index. Zero. If index plus plus equals 0, then we do read documents. Is that the right name for it? Source file. Reads source file. And there we pass compilant info and function info. Compilant info, function info, and p line. P line. And then we do read line, and there we just pass function info. Okay, then here we create a function. We comment out this one, read lines. We don't need, I think. Let's comment this. read line, read source file. So here we put compilant and function info. And read line, we just put these two. Okay, let's do read line first because that will be simpler. Read line. So to do, so we have long. Oof. So we have a lot of data, VA. So it'll be really a lot of data. No, it's okay. Okay, DW VA. Okay, so let's put here. So this is equals ulong 0. Dwords 0 0 0 0 length 0. Okay. Read line. I'm a bit worried about the sheer amount of data. Source line info. Length. Let's put let's not do PDB address here. That's a waste. Let's do line number. Let's do offset. Yeah, offset to address basically. Yeah. UN32T offset. That's better. As for offset from function address. This is line number in document. Length in bytes. Length in assembler bytes. Length of assembler bytes. Okay. Okay, I think this will work. Then, so we don't need we just take the WRVA if let's put if that and that and that. Yeah. Oh, let's write this a little bit better. H results HR1 equals this line num length 2 3 if HR this and this, if all okay, then function info. We can also do let's go back to read line before we forget it. P lines. I think P lines get count long count equals 0. Let's put a scope here. Get count and we do function info dot source lines dot reserve new capacity count. On that note, actually, I think what we can also do is compile and info. We need to pass this here. We also have this here, function IDs reserve count. Here, compile and info. wonder if we should also here source files dot reserve count, because our base expectation is that there's one source file for one compilant, although compilant also can contain source files which are not relevant for us, if I'm not mistaken. I could be wrong. We will see. We will see. Still figuring things out. Okay. So back to our function. So if all these things have passed, which by the way is wrong here, get length, there we go. So if these things have passed, then we do here and place back function info dot source lines and place back. Then we go source lines, source line info equals source lines dot back line info dot we should probably also get this here, source file ID. Dwords source ID. H results HR 3 equals source file ID P 3 4 line info dot sorry no, let's first get this one here, right? HR4 I have to say I don't quite like the separation here. Maybe we should put it in here, but then we get this huge condition. Yeah, I don't know. Either way, it's not ideal. Okay, so what I would like to do is we put in a assert for function info dot source file ID equals so the cast uint32t this thing. Oh, they should mesh. And file info dot what is first here? Line number, offset length. Line number how about we put offset first, because it is obviously the most important. Well, line number makes sense. Okay. Okay, line number equals so the cast uint32t, and then we have length equals length, and line num, no, RVA, so offset equals this minus function info dot address dot rel virtual. Yeah, this should there. Yeah, let's remove this. Okay, let's remove this and this. Okay, so this should be our source lines collection. Yeah. Let's compile this. Okay. There's some errors here. Right. VB reader. Good. Let's compile once more. Okay. Okay, so this read line thing, it makes sense to me. I should populate it properly. Okay, now to the hard part, the source file info. The source file info, we need to populate it here in the source files, and then we need to link to it in the compilant info and in the source file info. The function ID, yeah, and here. So we need to populate this, this, and this. Yeah. Okay. Okay, how do we do this? I need water. Okay. Good. So we need okay, so the P line gets source file I need to copy that from here. So we need this. P source. Okay, what is in there? Checksum. Do we care about the checksum? Oh, I just realized there is already an enum here for call convention. Oh. Which means we can get rid of this thing here. Actually. Yeah. Let's put our unknown is -1. Calling convention. Okay, it means we can delete this stuff here. Great. Although perhaps we would like to keep our own types. Yeah. Let's how about we instead we do let's copy this thing here. Do not add any more. Function calling convention. Enum class. Is a copy of, yeah. Basically, the idea here having our own means that these structs can be decoupled from reading with the DR2 API, right? So like these things could be moved somewhere else and still be valid. Yeah. Is a copy of this. How about we call it CV call? CV call. Then let's rename this to call. To simplify it. Call. Shorter names. Okay, good. Okay, back to our function. Okay, so our source file. Let's get back to here. So there is a checksum and a checksum type in there. Checksum. Checksum. By checksum. CB checksum. Yeah, how about we put PDB source file, put a std vector and put a hash. Checksum. copy of dr2's cv call copy of this enum class cv source checksum. Okay, let's put here source file. We put here vector uint 8t checksum, and then here checksum type. Function IDs. Yeah. I think this works. So, source file, psource, get compilance. Oh. Okay, that's unexpected. So a source file can have multiple compilants. I thought it would have been the other way around. A compilant can have multiple sources. Looks like I'm totally mistaken. I wonder if it's possible to well, okay. Okay, now the question is, compilants. Yeah, I'm surprised. I thought there would be multiple files per compilant and not the other way around. So a file can have multiple compilants. Huh? files. Here, compilers. Okay, because, for example, we have this header here, right? ASCII string.h, and that's used in multiple compilers, right? So main.cpp and here, right? Okay, I think there is like an end-to-end relationship. So a compilant can have multiple files, and files can have multiple compilants. That's a relationship. Okay. Good. So I wonder if we should have on source file info, we should have a std vector index t with compilant IDs. Oof. Maybe. Let's see if we can easily build this relationship or not. Okay, so let's get our sample here. So we have get file name. Name. Get file name. If is okay, then function info dot address. No. Oh. Right. Read source file. I wonder. Print source file. I wonder if there is a way to iterate source files. So if we go to enum, find children, syntax. Syntax. Let's search for source file. Enum source files. But this is no longer related to DR2 SDK. Syntax compilant. Find file. Find file by ID. Aha. Find file by ID. Dear session. Dear session. Dear source file. Okay, unique ID. Okay, so what we could do is we could call this find file ID by counting just upwards, unless there is a way to enumerate files, enum source files, find file, but that's by compilant. Okay, how about we write a function bool read source files. Bool pdb reader reads source files. Okay, and here we have a dir session, and here we call this, and when we do dwords unique ID equals 0, and then we do while dir session find file by ID dir source file p source unique ID. If that equals as okay, I don't know if I should call succeeded or not on this. Let's start with succeeded first. Succeeded. Succeeded. While succeeded. P source release. And basically what we do, we populate the source files here. Source files dot now we won't know how many we get, so let's do source files dot reserve 1024 source files dot shrink to fit source files dot place back source files dot back source file info file info file info dot component IDs. But so read source files. Oh boy. Let's scroll down here. -1. source release. Source. Name. File info dot name equals util 2 UTF-8. Okay. Source files dot no file info. Is there anything else we can populate here? Oh, yeah, the checksum. Yeah. Print symbol. Source file here. Checksum type. Yeah. Dwords. Checksum type equals no, none, none. And then we have this checksum thingy here. Checksum. Let's put here if s okay. Let's put this in the scope as well. If okay, then file info dot checksum type equals static cast. This. Okay. Checksum type. We need a free string here. Free string. Okay, next. Checksum source get checksum. If checksum is okay, then file info dot checksum dot assign I think we can do checksum and checksum plus that, I think. Yeah. I should good. Yeah. I think this will populate it sufficiently. Yeah. P-source release. Okay. Okay, this way I do this because now we have the source files already populated with the correct IDs, and the IDs are basically our indexes here, right? So we use the same indices for our compilers and function and source files as the PDB does. So they are in sync. So we don't run into mismatches if we do some lookups. Yeah, and this should be good. Okay. Okay, so what we basically have populated is this stuff here. These three. But these not yet. Compilant IDs we don't know from here, do we? P-source. Ah yeah, we do. Compilants. Okay. And then what? Get compilants. Get compilants. Okay, what does this give? Get compilants. What does this give? Enum symbols. Enum symbols. Yeah. So I think what we can do is let's do p-enum compilants. P-enum compilants. Then we pass this. And then if get compilants. If get compilants. That's okay. Then Okay, let's remove this here. And this. Let's put this here. Okay, so get compilants. Get components. So components. P compilants. Here. P enum compilants. And then so these are the compilants that belong to the source file. And then here we build association. P compilants. And then we need something like a ID. Get yeah, that's a question. How does it have an ID? Let's look in this documentation. Compilants. Aha. Index ID of symbol. Okay, there we go. Get sim index ID. Dwords. Index ID. If index ID is okay, then by the way, we can also get enum compilants here. Enum compilants get count long count 0 count, and then we do file info dot compilant IDs dot reserve counts. Yeah, and then the magic of the C API. So many functions. And here file info dot compilant IDs dot push back index ID. There we go. Okay, this should be correct. Let's comment this out here for now. Let's see if this works correctly. So basically, before we go through the compilers and gather the functions, we already populate the source files. That's what we aim to do here. Read source files. Return this not empty. Yeah. Okay, let's see. Oh, we got a assert. Oh. Okay. I didn't want to go there yet. Ah. We need to move this up here. Okay, let's try again. And the assert was rightfully hit because we didn't have the association yet. Yeah, first things first. Okay, so this should now give us nothing. Oof. Oof. Okay, that is unexpected. So ID is not an index. Shit. That sucks. Okay, then our assumption falls apart. I need to look again. Find file by ID. Shit. Find children. So what if we look here? There's no... There's no... Oops. There's no source file thingy, sim tag, because it's not a symbol. But then I don't know how I can query that thing. Perhaps it's not accessible by index. Find file by ID. Symbol by ID. Find file. Read source files. Yeah. Okay, well, the alternative is we build our own indices. But that sucks. So this unique ID is not an index. Or is it? Perhaps, hold on. Perhaps it starts at 1. That could be. No. Perhaps we have to compare it with SOK. Nope. Man. That is... Fine. Okay, so down here on our read source file, let's put a get source file, okay, and then p source release, okay, and here we get source, get unique ID. Let's take a look at what this ID looks like. dwords ID. This better be good now. Put a breakpoint here. All right. 1. Huh? So the ID is 1. Why can't we find it here then? Where's it? Here. So clearly there's a file with a unique ID 1, which we have here. Find file ID by ID, unique ID 1. Find file. Dear source file. Well, that doesn't change a thing, but just in case, for robustness sake. Sure, actually, I mean, here we could also initialize. Actually, it doesn't matter. Let's not make the code more complicated than it needs to be. Shit. I don't understand why it's not finding this find file ID. Source files, read source files. Capacity 0. Reads. Why is the capacity 0? Ah, shrink to fit, of course. Okay, I don't understand this. I don't understand why it doesn't return as a result here. Perhaps it's a bug in the library. I don't see an error here. We have our session, we call this function, we pass a 1. We give it our pointer. We check if S okay. How about let's take this out. Oh, stop debugging. HR results. Res. Let's see what the result is. One or more arguments are invalid. Huh? Find file by ID. Can we search here, find file by ID? Will it find it or not? Oh yeah, it does. Nice. Specifies the source file identifier. Returns an ID as source file object. It represents. If successful, returns as okay. This method is typically used internally to the DR SDK. Not for public consumption. Find file by ID. I mean, I don't see how we pass invalid arguments. Like, that's a unique ID. Unique IDs. Ah, by the way, we would have to count up, right? Like here, plus plus. Yeah. I don't know. Maybe do it at the end. Unique ID plus plus or plus plus. I don't understand why this doesn't work. Must work. I appreciate though that the debugger shows like this, what this error means. That's nice. Yeah. I don't know. It should work. Find file by ID. Something I'm missing, maybe. I don't see it, but that doesn't mean it's not there. Sometimes we're just oblivious to the obvious mistakes. It could be a very obvious, or, well, not an obvious, but it could be a definite mistake on my part. But I don't see it. Happens sometimes. What we could do is, how about while let's put a unique here, unique ID. Small. Let's iterate through 1,000 of these. If continue, let's say start at 0, but my expectation now is that it simply loops 1,000 times and never finds it. No? Yeah, never finds it. Oh, it's expensive. Ah, well, plus unique ID, of course. Okay. Yeah, it doesn't work for some reason, this function. I don't see why. Don't know, no clue. Okay, then what can we do instead? Okay, then we do a different approach. I have an idea. So our compilant here. Source file. Name of the source file. But this is a different source file, the compilant source file. Okay. Yeah, this is unfortunate that this doesn't work. Would have been nice, but that means we have to do it differently. Okay, let's copy this crap here. Let's put a return here. Or let's simply comment out here, read source files. Okay, read compilants. Then what we do is here on read source file, We would have to iterate. No. Source file. P-line. Read source file. Oh, it's quite some overhead for every function. For every source file. Stop debug. Okay, so here we have get source file. Okay. And we have a unique ID. Let's call this source ID. If get source ID is okay. Let's do if we can do if source files dot size. Now in the Python flow here, if source file size is smaller than source ID, then we do source files dot resize source ID. Hold on. If ID is 0, then we need 1. So source ID plus 1, resize plus 1. Okay. So we resize if we get a new unknown source ID. Yeah. And then if source files dot source ID dot name empty. Basically, we don't have Intel on this yet. Then we populate it. Then we put here. Then we do this stuff here. And put this here. Populate or get source file info. Allocate room. Allocate room. Get source file info. It's quite expensive because we have this to do for every function. Yeah. So basically every function checks this and this. Okay, but it only needs to be occasionally it enters here. Yeah. It's not ideal. I would have liked to do it in the first pass, right? Because then we just hammer through, and here, and then everything is already prepared, but looks like we can't do this for some reason, so we need to build different way. Yeah, it's not ideal. Let's put a comment here. This is done. Does it this complicated because there is no enumeration for it. It does it this wait, let's say source file data is populated this way because there is no source file enumeration in DR2 and find file by ID function always fails. Fails for valid unique IDs. What I could imagine happens is that the find file by ID only works if we have something loaded already that references this file. So like, for example, that you have a compilant already allocated. You're looking into this right now, and then you can access a file by ID. Otherwise you cannot because it's not available then. So I suspect this is what happens. I'm not sure, but maybe it's that way. Yeah. Okay, but anyway, this should work here. So if this is smaller than that, then we allocate that. And if it's not yet set, the source file, then we get the source file info. And we simply do here source pdb source file info source, well, it's file info equals that, and then we put this here. If empty, let's call this populate allocate. Well, room is a bit bad word. Allocate files. Populate source file info. Okay, so we have a file name, a checksum, and compilants. Yeah. And this gives us the index ID. That's nice. Get unique ID. Good. Read source file. P source release is down here. Yeah. Okay. Are we missing any info here? File info. Let me see. Ah, okay. We don't have this here. Function IDs. Yeah. So basically here, file info. File info dot function IDs, and there we put dot pushback function dot info dot. Oh, we don't have an ID. function info. Well, perhaps we just put ID in here, un32t ID, and function ID. Let's see, where's this called read source file? It's here, index. Let's call this line index. Read compilant function. Let's put here t index. Wait, it's index t. ID. Read compilant function. Let's make this const. I think this will not compile. ID. ID. Compilant info. Function like this. Okay, and so we need function. Yeah. So compilant functions back and place back. Let's call this function ID. Let's pass a function ID here actually. Index t function ID. By the way, I realize now that here our naming convention is a little bit off here. Should be function info. Compilant info. Okay, and then we pass this here. Let's rename this to function info, compilant info. Integrated name. It's bad that the naming convention that was introduced in Thyme is absolute bonkers. It should always be camel case and not like a mishmash of the one with the underscore and then together is retarded. Okay. So something is wrong here. comma. Good. So we have function ID, and then we pass a function ID. Oh boy. Here. Function ID. Function ID. Compile and info. Function info. Function info. Function info. Good. So pushback function info. No. Function here. Index T function ID. And so we pass function ID here. Good. What do we need the function info for then? For nothing. Then we can remove this. Compile and info, what do we need that for? I'm not sure. I lost a little bit overview. I lost track of what I'm doing here. Compile and info is not used right now. Okay, hold on. So we have file info. I'm stupid. Function info. File info. Okay, so we put here function info. Dot source file ID equals static cast un32. Wait, index T source ID. There we go. Okay, so we got this association. This one. Okay. We also have this association to here. We have this one as well from down here, yeah. But we don't yet have source file IDs. But there is here we have this files. Let's check it. Files. Here. Enum source files. Find file. Ah, find file by compilants. Right. Okay. So every compilant could contain multiple references to the source files which were used to build it. Retrieve all source files by compilant by passing null. Okay. Let's copy this. Let's go to our compilant. Man, this API is wild. Read compilant. Here. Let's put it here. Every compilant could contain multiple references to source files. Put some dots here. Okay, enum source files. Okay. It means that we can already populate stuff here. Okay. That's good. So we have pip compilant, we have this thing. Pip compilant. How about we put this here in a and we put this in the scope as well, so that everything is nice and tidy. Okay, so we have enum source files, enum symbols. By the way, this one, let's remove this one here. Let's rename this to enum compilants. And this to enum okay. So if succeeded, P session, that is, what is P session? Dir session. Yeah, dir session, find file, compilant, enum source file, P source file. Okay, then we put here. Oh boy. Populate source file info. Yeah, so we take this here, this copy. Oof. This. Let's take it. And we put it here. I wonder if we should put it in a different function. Let's put a void read source file, another one, which will contain. Oh boy. Let's revert this. So read source file here, and we call it with this, and that's it, just that. P source file. So we take this, I put this here, and then we go here, here, here. Oh man, that's so complicated. Read source file, PDB reader. Okay, and then we copy this here, copy. Let's cut it, put it here. So we need to get the ID here, source ID. And you put another here. Okay, if there is no pure. Okay, so source ID equals source ID. Then we remove this. And then we remove this. And yeah, here we allocate the files. And then we write to them here. P source file, source file, source file, source file. Here, file info, compilance, reserve. Yeah. This probably works. Yeah. So basically there's two steps. Like we go through the compilance and there we look which files are in there. And then we build those files. And then later when we go through the functions, we touch those source files again to fill the rest. That's what we do right now. Source file data is populated this way because there's no pure source file enumeration DR2. And find file by ID function fails for valid unique IDs. Function specific info is filled later. It's filled elsewhere. Okay. Then read source file info. Okay, and then here we have read source file. Let's get to that. Oh, now we deleted some info which we would have needed here. So function info, compilant info, compilant info. Hold on. We are missing. We also have to pass this here to here. Oh boy, compilant info. Oh, this stuff. Okay, read source file. So here we need to pass compilant info. We also need to rename it, by the way. Well, we need to make a refactor pass on it. Compilant info. And you know what? I would probably stick to camel case because we use the DR SDK as a sample, and there it uses this naming convention as well. So screw that. Compilant info. Let's get back to how it should be, like that. Good. Oh, I will make another pass later. Okay, so we have this read source file. Let's get back in there. Get in here. So we need to compilant info here, source file IDs dot pushback source ID. There we go. Pushback static cast UN32T source ID. There we go. I think we can save on this. It's okay. Okay, and read source file. Let's go back there once more. We can also here p source file. No. Here, pnum source files, get count. Oh boy. Dwords count 0, count, and p compilant info dot source file IDs dot reserve count. Boom. Okay, something's wrong here. Long, right? Long. There we go. Okay. Let's rename this back to what it was. Pilot info. Okay. Okay. This should be correct. Compile and info, yeah. Okay, and here we now yeah. And here we do compile and info. Function info. What is this function ID for now? Right, so we need this function info source file ID, file info dot function IDs dot pushback function ID. Now the question is function reserve. Oh, that is wrong. What am I doing here? Don't I need to fill it somewhere though? Just in file info then. File info dot function IDs dot pushback. Just here. Could be. Oops. Here. Function info source file ID this, and compile and info does nothing here. Okay, let's remove this. Read source file. So we remove this one here. Compile and info function info function ID. Function ID. File info. Good. Then actually we can also just simplify this to that. Put this here, delete that, done. Push back. So we basically just do the ID assignment. Read source file. So we put the function info source file and source files. Put the function there. Yeah, put this link between function and source file. Yeah, that makes sense. Okay, read source file. Let's check that. So here we call function info and function ID. ID. Good. I think we're making progress here. Let's rename all this crap back because we are brain dead. Yeah. Compilant info. Compilant info. Good. Okay, if I'm not mistaken, maybe if I did everything right, it works now. Could be. Could be. Oof. So we have compilants, we have source files and functions, and there's a relationship between source files and compilants, and zwischen compilants and functions and source files. So all these three have relationships here with these IDs, indices. Source file ID. Well, this one doesn't have a... Maybe this one should also have an index to the compilant. Yeah, maybe. Index t compilant ID equals 0. Let's put these up here. Okay, so we need to set this compilant ID. Compilant ID. Where do we do this? I think we do it on reads compilant symbol. Oof. Here, find functions and place back. Functions. Why do you put it here? Function ID. Let's put it, I'm losing track here. Let's put it here. M functions dot back dot compilant ID equals M compilants dot size -1. Static cast index t function IDs index t static cast here auto function ID pushback function ID let's put here const auto compilant ID equals this compilant yeah, this should work. Let's put a breakpoint in here. Let's go in here and put a breakpoint here. Yeah. And we put a breakpoint here. Yeah. Good. Let's see if it compiles or if we made a mistake. Yeah, we made a mistake. Ah, okay. This one is unknown. Struct source file. Maybe we should sort these. Session symbol. Let's try again. Okay, let's see. Good. So we have enum source files. Okay, we have a count 3. Good. So we reserve this with 3. Great. Now it's reserved. Fantastic. Then we go in here and compilant info shows us this, yeah. Here we have unique ID 1, pushback 1. So now here it becomes interesting. So we need a size 2. So source ID plus 1, and this will resize to 2. Capacity is 2. Source files. Source files, did we ever reserve? Hold on. Source files dot reserve. No, we removed it. And we no longer call this. Okay, then we put this back here. Read components. Components reserve. Components. Yeah, let's function source files. Let's put this back in then. Yeah. It's okay, we can reserve here. Compilance.clear. Okay, source files.clear functions. Is this in order? Source files. How about we change the order here. Compilance, source files functions. Compilance, source files, compilance, source files. Okay. Good. Let's stop this. All right. Good. So source file component. Good. So here we reserve this read source file. We go in here, push back source files. So this should be 2, and reserve should be much larger. 1024. File info, yes. So this one has a name empty. So we populate the name here. Yeah. Okay, and then we have a checksum. None. No checksum. Compilant. Count. Compilant IDs. Count 1. Okay, so this file has 1 compilant. Index 2. Okay. Okay, good. Okay, I assume this will be correct then. Okay. Let's also put some null pointers here. Well, it's not really necessary. Let's remove it for performance, in the name of performance. Yeah, we are cheap. We want it fast. Go fast. Very fast. Okay. Then let's go back. Compile. Good, so this succeeds, and now we go here. Good, so compile and ID is 0, yeah, makes sense. And function ID is also 0. The function ID is what we invent. That has no reference, as far as I'm aware, to the original. Okay, so here we push that function ID in there. How about we put a comment here? Synonymous index, synonymous for index matches DR2 index. Put a comment here. Compilants and source files indices match DR2 indices. Yeah, everything well documented. Okay, let's skip over this here. Yeah, good. So component ID 0, function ID 0, pushback and place back, function IDs, capacity. Capacity. Did we ever reserve this? Yes, we did. Here, good. Then here, functions back, compilant ID. Zero, compilant ID 0. Yeah. I do wonder if functions, since multiple since the same file can be in multiple compilants, I actually wonder if multiple functions can also be in multiple compilants. In that case, the association in that case, the association would be wrong. We can assert this. Let's check this. So we put here -1, -1. And then here we put asserts functions back compilant ID equals -1. Yeah. Let's get function info. Function info equals function info equals back compilant here. Good. Function info, function ID. Do we still need to pass function ID though? Yeah. Looks like so. Oh boy. Okay. So basically we should also assert read source file, and we assert source file ID. Source file here. Asserts source file ID equals -1. Yeah. So it would be interesting to see if one of these asserts hits. My suspicion is that this does not hit, but the one with the compilant ID, I suspect that will hit. Yeah, let's restart. If that's the case, we need to break that link from function to compilant, which, yeah, it's just removing code then. Good. So, yeah, this is the first one. So, obviously, that should pass. Good. And actually, it can never hit that assert, because if there were duplicate functions, then it would simply add a new function entry anyway. Yeah, we will see. What is this? Ah, okay, find lines. Let's look at this. Count 1. Find lines. Okay. Read source file. Source ID 1. Function info. Source file ID is -1. Source ID sets it now to 1. Yeah, we have some empties here because they weren't visited yet, but that's fine. Good. Read line. Let's see if this looks good. Okay, 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 okay. Source lines and place back. I do wonder, do we have a reserve for this? Yes, we do. Good. Line info. Mm-hmm. 15 offset length. Okay, let's watch this a few more times here. Let's get to a case where we have multiple lines. Oh, here we have 0. Let's put a breakpoint here. 0, 0, 1, 0. Four. Okay. So it should first go in here. We have a source file of ID 4. Source file ID 4, source 4. Source ID 4 here. Function IDs. Component IDs. Okay, and then read line. Source lines. Back. Yeah. Line number. Offset 0. Length. Yeah. And so then the next should be read line. Capacity 4. Source file 4. Line number. Offset 22. Length something. 8. So next should be at 30. Okay, this looks good to me. So we get the source lines. Whoa, 73. Good. So we have the full association. Yeah. Good. Let's run this through and see if it goes without any errors. Let's put a breakpoint here. And it ran through. No asserts. Okay, let's see. So we have 32 compilants, 53 source files, 282 functions. Okay, let's open our watch. So we have source files here. Okay, our compilants. Yeah, we have seen this before already. Let's look at some of these. So here we have function IDs 24, source file IDs 2, 3, 13, 1, 4, 8, 34. Yeah, okay, good. And here should be different indexes. Yeah, this looks This looks correct to me. Oh, critical section has nothing in there. Okay. Okay, but there's no gaps. It's all good. Okay, let's have a look at source files. Okay, so we have a bunch of empty files, but I guess then that's just the way it is, that there are some empty files. Yeah. I don't know why that is. But it's not the end of the world. What we can say is compiles the source in as match. Source files may contain invalid entries. Source files may contain. So what we can say is source file info. May contain unused entries. How about that? Unused entries. Yeah. So what we do is we put a source file info bool is used, const return name dot empty not, yeah, and then we go to read source files, read compilings, read source file here, this one. We go in here and we put if not is used, or maybe we should have better name is used is valid. How about that? Is valid. Yeah. So basically all these empty ones. I don't know why it is like this. Perhaps they are reserved for something but never picked up by any compilants, right? They're just empty files, maybe. I don't know how this happens. Must be a reason to this. But okay, to keep our data association simple, I would like to just have a vector. And if there's some empty files in there, whatever, then it is like this. Who cares? I think this struct is not large. Source file info is 144 bytes. Yeah. Oof. String is actually really large. Wow, 40 bytes? Ah, because it's debug, right? In release it should be smaller, 24 bytes. I think this is large because it's debug, but I'm not sure. I could be mistaken. I thought it's 24 bytes std string. Okay, let's look at this once more. Okay, so source files still is the same. Okay, so ASCII string, one compilant, 23 functions. This one is empty. Weapon, one compilant, 6 functions. Now we can also compare this against our text file to see if it's really all right. But I think we are golden here. STL port, alloc. Okay, that also has function. Component IDs. Yeah, of course. The STL port is part of the project. Actually, most of it is actually STL port. Yeah, there's not much in Thyme NG right now. That's why this list is so empty. Thyme NG is a new project where the goal is to really just put all the functions that are 100% verified correct. That's the goal. And that's why right now it's just so empty, because all the rest is in the normal Thyme repository, but there we didn't have the checks, right? Whether or not it's definitely correct. Okay, how about we look into Visual Studio 2022. Let's open. Oh, we can't. Let's go to Projects, Assembly Armada, Thyme NG, Source, Game Logic, Game Engine, Source, Game Logic, Objects, Weapon.cpp. Here. Edit. So in there should be 6 functions. 1, 2, 3, 4, 5, 6. Yeah. Okay. 6. Good. So this is correct. Then what we should also check is if functions. Oh, what is this? Source file ID is -1 here. Critical section. Okay, because these are. Yeah, okay, but this is correct. These are just system thingies. Yeah, okay. Source file ID. Yeah, how about we put PDB function, PDB here. So compilant should always be set, right? Compilant. Synonymous for index matches DR2 index. Never -1 is never can be -1. Can be cannot be. has bool has valid source file ID. Const return source file ID smaller 0. By the way, t-index ID. Oh, it's a uint. Let's do t-index 0. Let's leave it at -1. But this is then wrong. -1. It's not minus. I realize that my naming is again off the charts. Let's at least do consistent function names. Okay. Is valid. Okay. I think this works. Let's look at some here. Some function here. No, that's not a good function. Yeah, here this one looks good. Name key generator, reset. Name key generator. Let's go to our Thyme ng. So it's reset, right? Let's take this here. Okay, so this one has 4 lines with length 3, 5, 11, 1. 3, 5, 11, 1. 3, 5, 11, 1. Number 28 until 31. Yeah, this is correct. Okay. As far as I can tell, everything is correct. We populated all the data correctly. Yeah, I'm very happy with this result. The cool thing is that also we didn't need to build any lookup tables. We just have flat data, just continuous memory. That's it. No maps, no maps, no sets, just vector. Very nice. Okay, what about our checksum? Um, checksum here, Unicode string, no checksum. Okay, so it doesn't save checksum here for some reason. Okay, well, not a big deal. Okay, or maybe we made a mistake with the checksum. Let me see. Checksum assign. Checksum type. No. No, seems to be fine. Good. Then how about we clean up what we currently have? Let's stop debugging. Copy of that. Copy of that. Copy. Okay. Synonymous for index can be -1. Cannot be -1. Okay, let's remove all the garbage here that we no longer need. Read public function, source, line, source file, source, read source file. How about we rename this one? Read source file, read source file from line. How about that? Oh, now it changed this here as well. God damn it. Okay, let's rename this manually from line. Let's go to read line, read source from line, and then we need to call it. Here we need to change that. Here. Read source file from line. Find lines by VA. Source file from line. Yeah. This works. This works. Okay, let's compile and continue cleanup here. Okay, short and sweet. Let's clean up this here as well. Delete all this junk. And this junk. Source data file. Here. And this. compilance reserve. Yeah. Shrink to fit. Source lines shrink to fit. I think we don't need that because this one is actually reserved at some point. Yeah, it is. So we can remove this. And I think this shrink to fit won't happen because it's also reserved. But this one needs to shrink. Read compilance. Success. Yeah. Yeah. Let's see if there's any more garbage we need to delete. Sorry. No. No. Perfect. Perfect. Let's open our Git. Unassemblize. Let's push it. Okay, so we have a util header. Okay, let's review this carefully once more. I already see an error. Well, not error, but should be cleaned up here. Unordered map, throw that out. Done. Okay, int save. That's for dwords. Yeah. Okay, okay. Enum class. Copy of. Okay, address. Apps virtual, relative virtual, section offset, line number, address, debug start, links, decorated name, undecorated global name, source lines, is valid, const, not name empty, name, sums. Okay, read symbols, read source files, read compilance, read public function, co-initialized, false, co-initialized. Do we use it correctly? Okay. Let's make this separate line. Okay. Then let's put. Yeah. So this header looks good to me. PDB reader. Okay, success, false, read symbols, PDB read, PDB reads. Huh? Reads. Loads. Okay, here success should be here. Success. Read symbols. Load. That's okay. Yeah, this looks correct. Okay. Load first doesn't unload. That's fair. Co-initialized. Okay. To UTF-16. Yes. 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 Read symbols. Yes. Generous reserve. Read source files. Unique. Ah, hold on. This function here is unused, isn't it? We didn't end up using this one. This is not called, so we can just delete it. Yeah. Read source files. Yeah, which is too bad. It would have been a nice function. But okay. We managed without it, so that's fine. Okay, let's compile once more. Good. So here we remove this stage, CMake, stage. Okay, let's look at it. Let's make it larger. Good. So read compilants. Yeah, there's all that. Read compilant to symbol. Some comments here. There's a lot of skeleton stuff in here, but it's fine. Read compilant function. That's fine as well. Everything in there is useful. Could perhaps be broken up into more smaller functions here for these things, but I think it's fine. Compilant this, command function end, read public function, read source file. Read source file from line. Yeah. And read line. Read line. Yeah. Okay, then let me go once more here. Read source file. Read source file from line. Where's this called? Here. Yeah, read compilant function, read source. Okay, yeah, I think that it's okay. Function ID. Yeah, I think it's all right. There's one more thing we can do. That is put an end line here at the bottom. Ah, it does. Okay. Good, it compiles. Let's run it once more to check that we broke nothing here in the process. Here, breakpoints, watch, source files, compilants, functions is here. Has addresses, has a length, has a call, names, has source lines here. Perfect. Good. This this is very good. All right. Then Good. Implement PDB reads for all function symbol relevant. PDB read implement PDB reader to read all function relevant data and build flat data structures. Okay, good. And then with this flat data that we have just extracted from the PDB, we will then first generate a JSON, which can we then load back. And then we use that data to build the same assembler format that we have for the game executable currently built. And then we see how that compares. Yeah. Good. I have progress implementation for reading compilant source implementation for reading all compilant source file and reading all compilant source file and function data from PDB with what is also dir2 is done, pushed to branch, source files and function data from PDB with dir2 is done, push to branch. Next steps, dump info to JSON, read back, dump info to JSON, read back, then generates the .s format to see. Yeah. the ASM file. Generate the text file. Loads, save loads, info is JSON, generate the ASM text file for Thyme.exe. Then we can see, yeah. Good. Okay, very good. So all the reading, as far as I can tell, is done. We have a lot of data that we can work with, more than what we currently need to generate the ASM file, actually. And yeah, next steps I just wrote down here. Good. Then that has been 4 hours, 25 minutes. Oof. Well, certainly good effort. Yeah, I hope you enjoyed. I wish you a great day or night. Until next time, goodbye.